Hello all, I hope you had a wonderful and restful spring break. We're going to go ahead and get started with the first portion of today's learning segment. So our first section is going to be a video that's going to help us review explicit and recursive equations. So I'm going to go ahead and share my screen with you and we're going to go through a presentation. All right. So we have here, this says Chapter 5 Review. We're going to go ahead and take a look at some of the vocabulary that you need to know from Chapter 5. So if at any point you want to write this down, which I would highly recommend, you need to pause the video and then take your notes. Make sure you have a notebook and your pencil and paper with you as well. So if you need to pause and go get those things, I would recommend doing that now. So Chapter 5 Review, we're going to be going over arithmetic and geometric sequences. So for our first chunk of vocabulary review, we're going to be looking at sequence, term number, first term, initial value. So sequence is an ordered set of numbers, usually written in a list of numbers, which you guys have seen before. The term number is the term or the number that gives the position of a term in the sequence. The first term is the initial or starting value of a sequence, and this is very important to note that it is written as T1. The initial value is the 0th term. The term before the first term is written as T of 0. That's kind of a, we'll go back to that slide for just a second. This is kind of a throwback to our function notation that we went over a lot in semester 1. So T of 1 means that this is the first term, and T of 0 means that this is the 0 term in the sequence. So you might have to do some calculations to find those, but we're going to go over how to do that in a little bit. Okay, so in this slide, we have examples of a sequence where we have a sequence -9, -109, -209, -309, and then we can, and it keeps going. We'll go over how to find the pattern by which it's increasing in just a second, but right here, we can see that our first term in the sequence, pretty simple, it's -9. Our term number 2, so that would be the second term in the sequence, is -109. So arithmetic sequences are a type of sequence that are generated by adding or subtracting a constant to the previous term. So in this sequence right here, we can actually see that this is an arithmetic sequence. Arithmetic sequences are linear, and their domain is all real numbers. So that means you can plug anything in and get any result in an arithmetic sequence most of the time. All right, and then this right here, like we just discussed, is an example of an arithmetic sequence. The common difference is -100. So to get from 9 or -9 to -109, you're going to subtract 100. And the initial value, or the 0th term, is T of 0 equals 91. And we got that by adding 100 to -9. So if we needed to find the 0th term, we could do that just by adding 100 to this 9 right here. T1 is -9. Geometric sequences are generated by multiplying a constant to each previous term. Geometric sequences are exponential, and their domain is the natural or counting numbers. So geometric sequences are going to keep growing like this and not going to stop. The common ratio, and this right here is an example of a geometric sequence where we have -1, 6, -36, and 216. So we can see that they grow really rapidly. Like it starts off really small with -1, and then it keeps getting bigger and bigger and bigger. The common ratio right here is -6. We're multiplying by -6 to get from the first term to the next term. And then the 0th term, or the initial value, is T of 0 equals -1. And we got that by dividing the first term by -6. So -1 divided by -6 is going to give you 1/6. Or you can write it as a decimal, but I left it as a fraction. All right, and that is it for our vocabulary. We're gonna go ahead and look at some examples. So I'm gonna stop recording. All right, so we're gonna go ahead and now go over types of sequences. We have explicit sequences and recursive sequences kind of given here in our definition. So you guys probably remember from chapter 5 when we defined these, but I think a good refresher will help you guys be more confident so we can readdress those standards that you guys may not have done so well on the test. So an explicit sequence lets you calculate the value of any term t of n, where t of n is our term value and n is our term number. And we're going to go over some examples for what that looks like in a little bit. Try and make this a little less blurry. Okay, sorry. And we're going to go ahead now and look at our recursive, and then we also have recursive sequences. And recursive sequences are different from explicit sequences because they depend on knowing the previous term and also the first term. So we have our general form of these sequences. Arithmetic sequences take the general form t of n equals mn plus t of 0. Sorry, those are not recursive sequences. Those are explicit sequences. So t of n is, like we talked about already, our term value. So it's whatever the value of that particular term is going to be. M is our common difference in our arithmetic sequence. So that is whatever our common difference of that particular sequence is going to be. And then t of 0 is going to be the 0 term or initial term. All right, make that a little bit more legible. This might be a good pause point if you want to get these things copied down. Okay, and then we're going to look now at our recursive sequence, where we have t of n plus 1 equals t of n plus m. So t of n right here is our next term. So it's going to be whatever the next term in the sequence is. T of n is our current term or our previous term, wherever we are, whatever that value is. M is going to be our common difference. So it's whatever we add or subtract to the next term to get the, or to the previous term to get the next term. And then t of 1 is whatever our first term equals. So let's go ahead and now look at our geometric sequence. So this might be another good pause point for you to copy down some of these information. Geometric takes the general form. So for the explicit sequence, geometric takes the general form t of n equals t of 1, so our first term, times r to the n. So t of n is our term value again. So there are some commonalities between this and the arithmetic sequence. T of 1 is our first term. So it would be whatever our first term equals. R is our common ratio. And then n is our term number. I'm going to write that down here so we can see it, but I'll draw an arrow to it. And n here in the geometric sequence is actually the same as it is in our arithmetic sequence. I just forgot to define it. So n still equals our term number. Okay. So now we're going to go ahead and look at the recursive form of a geometric sequence. So it's pretty much the same as the recursive form of an arithmetic sequence. The only thing is, instead of adding our common difference, we're going to multiply our common ratio, or divide our common ratio if it was a division sequence. So same thing here. We have our next term, and then we also have our current term, and then we have our common ratio, and then this right here is still just whatever our first term is. So first term in the sequence. All right, so maybe take a second to write that down. We're going to go ahead and look at some examples. So I'll give you about 30 more seconds. Go ahead and pause the video if you need to. All right, so we're going to start here with this geometric sequence. We're going to write both a recursive equation and an explicit equation with it. So I'm going to start us off with the explicit. So we're going to follow the form up here, t of n equals t of 1 times r to the n. But first we need to probably find what our common ratio is. So we get from -1 to +6 by multiplying by -6, okay? So this is what our common ratio is. And I'll move my hand so y'all can see. Okay. And then our first term, right here, t of 1 equals -1. So our explicit geometric sequence is going to be t of n equals -1 times -6 to the n power. And it's the power of n, not times n. All right, now we're going to go ahead and look at our recursive sequence because we already know all the things that we need to know. So our recursive sequence looks like this. We have t of n plus 1 equals t of n, pretty simple, times our common ratio, which is -6. But we also have to write what our first term is. So t of 1 equals -1. And that's all we got to do. All right, so now we're going to go ahead and look at the arithmetic sequence given here. So we need to go ahead and start with our explicit equation. The nice thing is this is very similar to linear equations, which we've been working on this entire semester, an entire year, in different forms. So to get from -9 to -109, we subtract 100. So that is our common difference. So our common difference is -100. And to write our explicit equation, we follow the form given above. T of n equals mn plus t of 0. Let's actually really quickly find our 0 term before we do that. So t of 0 is actually going to equal -9 plus 100. So we're going to do the opposite operation of subtracting 100 to get to our 0 term. So -9 plus 100 gives us +91. And now that we know our 0 term, we can actually write our explicit equation now. So we do t of n equals our common difference, which is -100, times n plus 91, which is our 0 term. All right. And then for our recursive equation, we're going to follow pretty much the same pattern as we do for our geometric recursive equation. We have t of n plus 1 equals t of n plus 91. We're not multiplying this time, we're adding. And then t of 0, or I'm sorry, not t of 0. And that I messed up on because it should not be plus our 0 term. It should be minus 100. So it's our common difference that we want to subtract from t of n to get our next term. T of 1 is going to equal -9. And we can just see that from the equation, or from the sequence.